Chapter 14, Section 14.1, EPO experiment. EPO treatment scores tend to be slightly larger than the control groups, a tendency supported by a mean difference of 5 minutes in favor of the treatment group. A t-test for 2 independent samples, which evaluates the mean difference of 5 minutes relative to its variability, helps interpret this tendency. 2 independent samples. Independent would be observations in each sample are based on difference in unmatched subjects. 2 populations can characterize a sample of patients as if it were a random sample from a much larger hypothetical population. 2 hypothetical populations, a treatment population and a control population. Both are cited in the null hypothesis, and generalizations must be viewed as provisional conclusions rather than logical or statistical necessity. Difference between population means. Effect refers to any difference between 2 population means. If EPO facilitates endurance, the scores for the treatment population would tend to exceed those for the control population, and the difference between population means would be positive, more positive when a stronger effect. Negative difference between population means if EPO hinders endurance. Section 14.2, Statistical Hypotheses. Null hypothesis would be the difference between the mean endurance scores for the treatment and control populations is less than or equal to 0. Alternative or research hypothesis occurs when the difference between population means is positive because EPO facilitates endurance. A directional alternative hypothesis should be used when there's a concern only about differences in a particular direction. 2 other possible alternative hypotheses. There's the one-tail test with a lower tail critical and a non-directional 2-tail test. Section 14.3, Sampling distribution of differences between sample means. Sampling distribution. Differences between sample means based on all possible pairs of random samples from 2 underlying populations. It represents the entire spectrum of differences between sample means based on all possible pairs of random samples from the 2 underlying populations. Means of the sampling distribution. The mean of the sampling distribution equals the population mean. The mean of the sampling distribution difference between sample means equals the difference between population means. Any claims about the difference between population means can be transferred directly to the mean of the sampling distribution. Standard error of the sampling distribution. Standard error of the difference between means is a rough measure of the average amount by which any sample mean difference deviates from the difference between population means. If the observed difference between sample means is smaller than the standard error, it qualifies as a common outcome, while within the average expected by chance, and the null hypothesis is retained. If the observed difference is larger than the standard error, it qualifies as a rare outcome, and the null hypothesis is rejected. The size of the standard error for 2 samples becomes smaller with increases in sample sizes. Section 14.4, the t-test. A t-ratio is when t equals the difference between sample means minus the hypothesized difference between population means, all divided by the estimated standard error. Finding critical t-values. We must consult Table B and Appendix C to determine critical values that distinguish between common and rare values of t on the assumption that the null hypothesis is true. Summary for EPO experiment. The calculated value of t, 2.16, exceeded the critical t of 1.812. Therefore, we can reject the null hypothesis and conclude that on average, EPO increases the endurance scores of treatment patients. The difference between the population means was greater than 0. There is evidence that EPO increases the mean endurance scores of treatment patients.